All right, welcome to the last lesson in the first unit of our Math 2 section. Okay, we're going to be talking about how to graph quadratic, absolute value, and piecewise defined functions. All right, let's get started. Okay, so by the end of this lesson, you should be able to graph a quadratic equation while using an XY table, graph an absolute value equation while using an XY table, and also be able to graph a piecewise defined function using an XY table. There's a key there. That XY table is going to help us when we are graphing more complicated functions. Okay, so quadratic equations are polynomials with the highest degree being 2, meaning if I have a list of stuff, so like 3x squared plus 4x minus 5, my highest degree is 2, meaning I have a variable raised to the second power. So that's what I'm looking. So that's what a quadratic is. It's going to look like a U shape. The parent function is y equals x squared, which is shown right here in this image. That's my most basic form of that function. A piecewise defined equation are equations that are written in pieces, meaning that you're given the equation of the graph, then boundaries on where this equation exists. So if we look at this image here on the right side of your screen, for this left part, this goes with this equation down here. X squared plus 3 only when x is less than negative 2. So here's 2 right here. Here's 2 right here. So it is only that equation for when x is less than 2, smaller than, which makes sense for right there. Then I get, let's change colors here, x minus 7 for when x is greater than or equal to negative 2. So one thing that's missing here is that should be a filled in circle. This is taken off our TI Inspire software. And up here on this x squared plus 3 is an open circle. Okay, and then my equation for this green equation, x minus 7, I'm increasing by 1, decrease by 7, 2, 4, 6. Each of these tick marks are 2, 4, 6, so 7 is my y-intercept. For x's that are greater than negative 2, so for everything greater we use that equation. That's a piecewise defined function. You like kind of break up functions and you give them boundary points of where they can live. A special type of piecewise function is called a step function. So every equation here is a horizontal line. F of x is negative 3 between these points, negative 2, negative 1, 0, 1. So they end up looking like steps. Okay? So oftentimes every piece will be the same interval. So notice all of these intervals are all extending 1 unit. So all my steps are the same length. An absolute value equation. Okay, so you should have done absolute values by this point. Now we're going to learn how to graph them just real quickly. This is really going to be really simple and really similar to how we're going to graph quadratics. They look really similar. Instead of having a U shape though, we get this nice hard V shape, nice point. Okay. Your absolute value is always going to have this V shape in it. Alright, so let's talk about graphing. How am I going to graph these crazy things? So like I said earlier in the video, is when I have a more complex function, we use an XY table. This is going to be your best friend. So we're going to find points on the graph, and then on the table, and then we're going to graph it. I like to find 3 to 4 points on each graph to make sure that I have like I'm confident what the shape's going to look like. It also helps to already previously know what functions look like. I know that for a quadratic or a parabola, I'm going to have a nice symmetrical U shape. For a piecewise, I need to understand what each component looks like. Is it going to be a U shape, a straight line, a V, that type of stuff. absolute value, I'm looking for that V shape that's also symmetrical. Make sure for piecewise functions, you have to find 3 to 4 points for each piece, okay? Because I want to make sure that I know what each piece looks like. All right, let's do some examples. So graphing the equation y equals 2x squared minus 4. Okay. So what I need to do for a quadratic, I always want to find my vertex. So I'm actually kind of in vertex form already here. If I just have a number here and I just have an x squared, there's no other x's in the equation, I know my x value is going to be a 0. And so my next step is I have to plug that 0 into the equation and find my output, my y value. So I'm going to say 2. Instead of putting x here, I'm going to input a 0. I square it minus 4. 0 squared is 0. So I get 2 times 0 minus 4. 2 times 0 is 0. And we get negative 4. So there's my vertex of that. The next thing I want to do while I'm writing is I want to find a point on the left of that and a point on the right. So something bigger and something smaller. So we're going to do, let's say, negative 1. So that's my smaller one. And then let's do 3. Okay, so I'm going to plug negative 1 into that equation. Negative 1 squared is a positive 1. 2 times 1 is 2. 2 minus 4 gives me a negative 2. Okay, so there's one problem. My next point is going to be 3. So I have 2 times 3 squared minus 4. 3 times 2 is 9. Or not 3 times 2. 3 squared is 9. 2 times 9 is 18. 18 minus 4 is 14. Alright, so I have my points here. I'm going to just graph these. 0, negative 4. 0, negative 4. It's right there. We have negative 1, negative 2, and we have 3, 14. So now that I have my points, I can kind of see that the shape should work. If I want, I can use my knowledge that quadratics are symmetrical and fill in this other half. Okay, and this is what I'm meaning by, I know to get to this point right here, I have to go over 1 and up 2. So I'm going to do the same thing. I'm going to mirror that point. Same thing over here. 3. I'm going to mirror that point. What that's going to do is it's going to, when I'm drawing this graph, it kind of helps me create a shape. I'm not looking for anything perfect, just so you get a basic shape of what this is going to look like. That's my quadratic. The next thing we're going to do is we are going to graph an absolute value equation. Now we're going to do exactly the same thing like we did for a quadratic. They're super similar in shape and just how they behave, how the functions behave in the equation. These absolute value bars are really similar to my parentheses, and this is essentially like my vertex equation. So I want to find my vertex, which is going to be right here. But remember, in my parentheses, vertexes are always opposite. And I put in, so I'm going to put in a negative 2 there. That's because if I input a negative 2 into that x, I replace that. Negative 2 plus 2 is 0. The absolute value of 0 is 0. And we're going to go minus 5. Okay, so there's my first point. Same kind of rules apply. I'm going to do something smaller and something bigger. So a number that's smaller than negative 2, let's do negative 6. Why not? And then let's do 4. 4 are positive. Okay, so we're going to plug these in. The absolute value of negative 6 plus 2 minus 5. Negative 6 plus 2 gives me a negative 4. The absolute value of negative 4, so whenever we're talking about the absolute value of a number, we're saying what's the distance away from 0, and distance is always positive. So negative 4 is 4 spaces away from 0, and 4 minus 5 gives me a negative 1. So I have negative 6, negative 1. The next one, we're going to input 4. So I get 4 plus 2, absolute value, right, negative 5. 4 plus 2 is 6. The absolute value of 6, meaning how far away from 0 is 6 units, minus 5, and we get a positive 1. So let's plot these points. I get negative 2, negative 5. We get negative 6, negative 1, and we get 4, 1, right there. So we're kind of seeing that Z shape right now. So what we're going to do is I need to understand absolute value. It's going to be that Z, that V shape, and create my graph. And that looks pretty good. That's symmetrical. We got those points on point, as some people might say. All right, let's do a step function or a piecewise defined function. Notice I have 2 different XY tables. That's because I have to find 3 points for each one. So we're going to start right here. I guess that arrow is pointing at like both of them. That doesn't help. We're going to start right there at this x squared plus 3. Right here are my boundary points. So I'm always going to include my boundary point here. And then I also want to include my vertex, or my vertex point. So in this case, it's going to be 0. And then notice my x kind of gives me a restriction. It has to be something that is less than 2. So 2 is my number that's bigger than 0. We want to find something on the other side of the vertex. So let's do like a negative. Let's do like a negative 3. Okay. So we're going to plug all these numbers in. 0 squared plus 3. It's just 3, right? 0 squared, 0. 2 squared plus 3 gives me, 2 squared is 4, plus 4, that gives me 8. And then negative 3 squared plus 3. Negative 3 squared is 9, plus 3 is 12. Alright, so I have those points. Now, we are going to do this next one, which is just x, which is an easy one. For x is greater than or equal to 2. So we have 2, 3, and let's just say 6. So when x is 2, y is also 2. X is 3, y is also 3. When x is 6, y is also 6. Okay, so my next step here is to plot these points. Let's just do... We just have to be careful because we have to understand what these boundary points mean. If I'm going to do a filled-in circle at that point or an open circle. If I can equal something, so we're going to do these orange ones first. It means I'm going to have a filled-in point. So at my boundary point, 2, 2, I'm going to have a filled-in point. Okay, so 2, 2. Right there, I have a filled-in point. And I get 3, 3, 6, 6. And then my arrow going, saying it's going to continue on. Now for my green one, notice my boundary, it can't equal. So this means I'm going to have a open point at my boundary. So at 2, 8, I'm going to have an open point. Notice I have to have this, so this is a function. Okay, then I have my point 0, 3. This one can be filled in. This is good. All these other ones. And then negative 3, 12. It's my other point. Remember, this is a quadratic function right here. I have to recognize that. So I know what this is going to do is it's going to come down and then come back up. there's my piecewise defined function. If you have any other questions, let me know. I might try to make another video talking about doing a couple example problems on the assignment that's listed with this, but I feel like this should be a pretty decent representation of what you need to do. But yeah, if you have questions, come and see me, come talk to a tutor. We're happy to help. Thanks.